Hello and welcome back to the second video involving how to compute standard deviation. We're going to begin with Dataset 3. First thing we want to do is take these values and put them on our number line. So if you recall, this was 0, 5, 10, 15, 20. So we have a value of 1, which would be here, a value of 7, which would be somewhere around here, and then we have 10. If you remember from the first video, there's not as much spread in this data set, so we expect the standard deviation to be smaller. So we list our x's, 1, 7, 10. To compute x bar, we add up the x's and divide by how many we have. So 1 plus 7 is 8, plus 10 is 18. So we have 18 divided by 3, which is equal to 6. Now the next step is to compute the deviations. So we take 1 minus 6 and we get negative 5. We take 7 minus 6 and we get a positive 1, and if we take 10 minus 6 we get a positive 4. Again, these add up to 0, so we have to square each deviation. Negative 5 squared is 25. 1 squared is 1 times 1, which is 1. And 4 squared is 16. So if we add up the deviations squared, we have 25 plus 1 plus 16. So this makes 42. So to compute the sample variance, which is denoted as square, we take 42 and divide by 3 minus 1, which is 42 divided by 2, which is 21. So to compute the standard deviation, all we have to do is take the square root of the variance, and we see it's the square root of 21. So if we look back at the first video, at the first data set, this is exactly the same value that we got from the first data set. And if you look at it, the only difference between Dataset 3 and Dataset 1 is a value of 1 has been added to each value, which changed the center. It changed the mean from 5 to 6, but it did not change the spread because all the values were just shifted over to the right one, and the spread was not affected. So this is why it would have the same standard deviation, because the spread is the same. This is our last data set. We have the value of 0, 12, and 18. So Dataset 4 has more spread than Dataset 3, so we expect the standard deviation to be larger. So our x's are 0, 12, and 18. X bar would be the sum of these three. 0 plus 12 is 12, plus 18 is 30. 30 divided by 3 is 10. So each deviation would be 0 minus 10, which is negative 10. 12 minus 10, which is 2. 18 minus 10, which is 8. Again, this adds to 0, so we have to square each deviation. Negative 10 squared is 100. 2 squared is 4, and 8 squared is 64. So if we add up these deviations squared, we get 100 plus 4 plus 64, which is a total of 168. So to compute the sample variance, S squared, we take that sum, 168, and divide it by n minus 1, which is 2, and we get a value of 84. So sample variance is 84. Standard deviation is the square root of the variance, which is 84, which is approximately the 2 decimal places 9.17. So this value here is larger than Dataset 3 because we have more spread. So let's summarize. Here's Dataset 1. Here's our values on the number line, and we see that S squared was 21, and S, the standard deviation, was the square root of 21, which was approximately 4.58. This is Dataset 2. We have more spread. This was the largest amount of spread. We ended up with S squared being 156, and then the standard deviation S would be the square root of 156, which is about 12.49. Dataset 3 had the same standard deviation as Dataset 1. The mean was different because these three values were shifted to the right 1 unit, therefore the mean would be shifted 1 unit to the right, but the standard deviation, square root of 21, is exactly the same. And the last dataset, Dataset 4, S squared turns out to be 84, so sample variance is 84. The standard deviation was the square root of 84, which is approximately 9.17. These two videos are to give you just an insight on what standard deviation means. So all problems involving standard deviation, you should use computer software, either Minitab or StatCrunch, or you should use the scientific or graphing calculator like the TI-83 or 84 to compute standard deviation. You will not be required to compute the standard deviation by hand. So again, this video was just to give you some insight on how standard deviation is computed, but more importantly, what does standard deviation measure? And it measures the spread. Thanks for watching.